Welcome everybody. I'm going to just give a couple of seconds for everybody to get in. Numbers are still going up quickly. Okay, good. Perfect. Welcome to our webinar, everybody. So today we're going to be building an endless runner game from start to finish using Machinations. Before we kind of get started and get into it, what we'd love you to do is down the bottom of your screen somewhere, I think, you should find a little chat button that looks like this. If you can hit that, and then if you change your option, so rather than just saying to all panelists, change it to all panelists and attendees, and drop into chat where you're dialing in from today and which studio you're from. It'd be great just to know where everybody is. And as we go through, we're going to be having some chat as well and asking for your input. Hi, Saeed. Fantastic. So I'm Matthew. I'm the evangelist for Machinations, and today, as always, I'm going to be joined by Cesar, our diagram master. Also in chat, we're going to have the legendary Mihai, who's far too shy for camera, and he's got his photo from 15 years ago on here. He's going to be helping us moderate chat and answering any questions and things that come up in the chat in the background. As always, we're going to have plenty of time for Q&A at the end, but please do ask questions as we go. Jump into the chat and bring up any comments you've got. And as always, we're going to be asking for your help balancing this via polls. And here's the first poll, which allows me to seamlessly transition between my screens. How complex are your machinations so far? So just let us know kind of how big your models are, how complex your models are so far. Give us an idea of how much experience you've got with the platform so far. Fantastic. I'm going to give it another couple of seconds and then I'll close the poll. Closing the poll in 3, 2, 1. And here are the results. So this is fantastic, good. Lots of people who have not used the platform before. This is going to be ideal for you. We're going to go all the way through. If you people are already doing your full meta, we're going to get to that point by the end of today's session and really show you how to, we're going to build quite a big diagram today during the session. So hopefully you can all see my screen. Cesar, give me the thumbs up if you can. Fantastic. So the first thing I'm going to do is I'm going to open from template and I'm going to start off with our intro tutorial step 1 of 7. And what we're going to do today is I'm going to go through the 7 steps of the tutorial really quickly, just to make sure everyone's got a common language and we will understand what all of these objects are doing. And then Cesar's going to take over and we're going to make this into a full endless runner game. So there's 11 different objects in Machinations. These are the most common ones. The first one is a source. This generates resources for us. The second one is a pool. A pool holds resources and resources can move in and out of it. If I play one step, you'll see that 5 resources were created in the source and moved over to the pool. That's because our connection, resource connection, has a label of 5. So each step, it's going to put 5 resources into our distance. And for our endless runner game, this is now simulating when the player starts, every step of the simulation, they're going to go 5 steps in the game. Nice and simple. Hopefully that will make sense to everybody. If I press play, it'll continuously carry on adding those resources. Now in the tutorial, there's the link here to open up the second one. I've got planned and I've opened this up for us already. So with the next step, this is just an example of that one source can actually provide resources to multiple pools. So if I hit the first step, 5 resources have come into here. The next step, 1 resource has come over to our difficulty factor pool. And the reason for this is on our label, we have 1 resource, and then it's got the vertical stroke, and then it's got number 2. So it's sending 1 resource every second step. And I could change that and make that 4. and then it would send one resource every 4 steps. So it just gives us a way of controlling how the connection behaves. I'll put that back to 2. Now, for our third step of our tutorial, we want to start rewarding the player with some resources for as they travel through the game. So I'm going to hit play. Our distance is gradually going to increase, and you'll notice that we then have a state connection connecting to another source. This source is then generating 1 coin per step. But because of this condition on here of 1.49, that means it's only going to make this connection active when the distance is between 1 and 49. So if I hit play again, you'll see resources are coming through, coins are being collected by our player, but then the second we get over 49, this source is then turned off. So we want something to happen for our player once they're doing well and they get past 49 steps. Now we've created a couple of different sources. These sources are then controlled via these state connections for different stages of the game. So at the start, the player is going to receive 1 coin per every 5 steps. Once they get over 50, they're going to receive 2. And then using the symbol of greater than 100, once the player's over 100, they're now going to receive 3 coins per 5 steps. So we've really quickly created a mechanism of building up our rewards depending on how far our players got through the game. Next, we don't want this just to carry on forever. We want to start creating a chance that the player has a crash. So now when I do my first couple of steps, we have a state connection going into a new source. Once this pool is then over 1, this then activates this source. This source is going into a gate, and this is a random gate. So these can be deterministic or they can be random. And with each step, there's then a 10% chance that the player is going to crash. I'm going to hit play because invariably, whenever you're doing a live demo, it's the luckiest player in the world and they'll never crash. And then eventually they'll get to a chance where there's a 10% chance that the player will crash at some point. It's always super lucky. There we go. So our player has now crashed, and that's now triggered this end game object. So this object will stop the simulation once its criteria triggered. So in this case, our player crashes are greater than 0, therefore it's game over. Please press F in the chat to pay your respects to our fallen player. I'm going to now move on. And I love gamers. And what we want to do is we actually now want to increase the difficulty of the game as the player progresses throughout the game. So I'll hit play again. Our players starting to add their steps, their difficulty factors increasing. Then we're using a state connection with a label of +1% into our resource connection to increase the difficulty. Therefore, the further the player gets, the greater chances of the player crashing. So it really immediately gives us a very simple mechanism to be able to simulate the increased obstacles, higher difficulty, the further they get through the game. Now, this is the 7th step of our tutorial, building the basis for our endless runner. This time, we've just added a couple of extra conditions. So rather than it being a fixed amount of coins that the player receives each steps, we're simulating a bit more complex player behavior where actually they might not be able to pick up all the coins. And we're doing that with a resource connection label of D10. So D10 means a 10-sided dice. So for each step that the player is going through this, they're going to receive between 1 and 10 coins. As the player then progresses through the game and they get into the high levels, they're then going to receive D20 and D30 accordingly. But they didn't make it that time because the player fell over. So as you can see, we've got a few different items in our model, and this is then simulating this basic game for us. So what I'm going to do is I'm going to rename this diagram. EU. I'm going to hit save. And then what we're going to do is I'm going to ask Cesar to come and join me in this diagram. And we're going to take this and we're going to expand this out a bit and make it into a full game. And I'm going to stop sharing. Does that work, Cesar? Are you joining?
Hi. I'm going to be sharing. So
perfect. All ready for you to share.
So this is the final step of our diagram. We're going to add to it. We are going to add a few systems. So first things first, let's get rid of all this needless text that we have here. That's taking our space. And I'm going to leave the model present in the 7th step here, so we can have a look at the end at how far we've come. And the way we've thought about building this is creating different instances of the game, different levels individually. So I'm just going to copy, paste it nearby, and I'm just going to work on this model that we have here. So the first thing we're going to do is we're going to add a life counter for our player. In most games, the player usually have a number of lives they can burn through. They don't just crash once and it's game over. So we're going to do just that now. And I believe Matthew is going to ask for your input now.
Absolutely. Well, how many lives do we want to give the player for each run? I've got 1, 2, or 3. We probably don't want to do more than 3. But pop in how many lives you think we should give the player. Brilliant. Results coming in super fast. I'll give it another couple of seconds and then I'll end the poll. So last chance to vote. 3, 2, 1. It's pretty close. We've got 3 as the number of lives we're going to give Cesar.
Yeah. So by popular choice, we're going to be giving the player 3 lives. That means that our game over end condition that we have here is not going to be triggered by player crashes anymore. We're going to have a separate pool in which we're going to keep track of our lives. I'm just going to name it lives. And since the vote said 3, I'm going to give it 3 resources, change the display to -1. So instead of resources, we'd see it as a number. So it's easier to keep track of them. And what will happen now when the player crashes, rather than going straight into the game over screen, we're going to have a drain. And we're going to use that drain to draw 1 life out of the lives pool. Now, how are we going to trigger this drain? We're going to use a state connection with a trigger label. So an asterisk label means that whenever the input node, which is player crashes in this case, so whenever the player crashes pool receives 1 resource, the outgoing node will trigger for a single step. So whenever the player successfully crashes, 1 life will be deducted from the lives pool. And in order to end the game, to have a game over, we're going to have lives condition that by equal to 0. So when we run out of lives, then it's game over. So our player should go much further now. So we can actually see how this affects gameplay straight away. I'm just going to hit play. Future executions, I think I'm going to speed it up a bit because we're going to see more of the same. So as you see, our player crashed. He lost a life. It isn't game over straight away. He's still accumulating difficulty. He's still carrying on. So okay, this is a good example. So when you do stuff like this, you see my first end condition from the initial diagram triggered the execution to stop. So what we want to do is we want to remove this condition We're just going to let this part of the diagram play over and over. We don't really care about it right now. We're going to focus on this one. I'm going to speed it up a bit, and let's play again and see how lives work. So we're accumulating again. Our player is dying in succession. He's losing lives. The game's getting harder for him. He's getting the distance. He's getting the coins. Hopefully he'll soon run out of his last life. Yeah, and as soon as we hit 0 lives, it's game over for our player. A popular mechanic that this sort of games have is usually when a player loses a life. As you saw in the last example, he lost 2 of them consecutively, so one step after the other. Usually the player becomes invulnerable for a few seconds, is able to clip through objects and scenery. So I'm thinking we should implement that as well, give the player a bit more chances to recover after losing a life. So the way we're going to handle that is we're going to create a period of invincibility for the player once the player crashes. We think that the duration should be around 5 seconds, so we're going to make it 5 steps. I'm going to move the chance of error label a bit to the right because I'm going to need a bit of space here. So how are we going to simulate that invincibility? We're going to have a pool that checks the state of our player. So I'm going to name this pool player is vulnerable. And I'm going to give it 1 resource because the player by default is vulnerable. So whenever this pool will have a resource, our player will be able to crash and otherwise not. What we want to do with this resource is move it away from the pool for 5 steps whenever the player crashes. So to use that, we're going to be using a delay node. A delay node stores the resource that it receives for the amount of steps specified on the output connection. So what this means is that we'll just juggle our resource back and forth between our delay node and our player is vulnerable pool. So we're going to be sending it during one step, we're going to be sending it to our delay, and then we're going to keep it for 4 more steps to amount to a total of 5. And after 4 steps, the resource will return to the player is vulnerable pool. Now, by itself, this construction does nothing right now because it's all passive. What we want to do is we want to have it triggered when the player crashes. So the same as the drain situation here, we're just going to drag a connection from player crashes. As soon as the player receives a resource, it's going to trigger the player is vulnerable pool. Now the player is vulnerable pool in the action property here is set to pull any. I'm going to set it to push any, so it pushes the resource forward. So now whenever the player crashes, the resource is pushed forward and kept in the delay for 4 steps. And again, this by itself still doesn't do anything because it's just moving a resource forward and backward. What we want to do with it in order to simulate the invulnerability, just going to drag the connection a bit like this. I'm thinking we should disable the chance of error gate that we have here. So same as we have difficulty factor here conditioning the spawn of obstacles, like once we have greater than 1 difficulty factor obstacles we can spawn. The same we're going to be doing here. Our chance of error is available so the player is able to crash only while the player is vulnerable. So the condition that we have by default greater than 0 should work just fine. So now I'm going to zoom in a bit and we're going to execute again and see what difference this makes. So we'll be accumulating difficulty, and as soon as the player crashes, there we go, our player went into the loop, chance of error was disabled for 5 steps, the player is unable to crash for a period, and after that it becomes vulnerable again. And as soon as he became vulnerable, he crashed again, and it was game over for him. So this is a simple invulnerable mechanic on respawn that the player can use. It should help him gather more coins than usual. And for our next constructions, I believe we're going to be introducing boosts, right, Matthew?
That's right. So we've come up with a few different ideas of boosts that we can give the player. So as always with our super interactive webinars, we're going to ask for your input. So the 3 ideas we've come up with are a speed boost where the player goes faster for a period of time, a strength boost where the player can smash through obstacles and is effectively invulnerable, then a mega jump boost where the player can jump high into the sky, leaping forward and collecting loads of coins. And we're going to call it the mega jump boost or the mega ultimate mega jump boost. I'm not sure, but it's going to have that sort of mechanic to it. So pop in your answers of what you'd like to see us build. Brilliant. We'll give it another few seconds for the poll. It's pretty close. And actually, so here are the results. So the number one is a strength boost, so the player can smash through the obstacles. But actually, I think we'll probably build all three. So let's do the speed and strength first, and then we'll do the mega jump boost last. And actually, the way in which we want to think about this is we want to build this as a kind of an onboarding journey. So we're going to have the first diagram be the game that the player is going to play the second they join. And actually, we want to introduce these boost mechanics to them gradually. So in the next game, rather than putting it all into this one model, we're going to leave this model as it is and then build the next model with the boosting, if that's okay, Cesar.
Yep. It's going to be the same as before. So we're just going to copy our already existing game, because maybe someone who builds the game wants to test them separately and maybe remove a couple of them. See, Matthew's already messing with me here.
Well, I'm going to get rid of that game over off the last one, so you don't forget this time.
Thanks for that. So now that I have backup, hopefully I won't screw up anymore. We're going to be focusing on this diagram now. I'm going to be building them in the order that they were presented. So I believe our speed boost was first, so I'm just going to start with that one.
Either the super strength or the speed boost, so that you have liberty to go which way you want.
Then let's start with the strength one, since it was the most voted, and I don't want people feeling robbed. So we're just going to start with the strength one. So the way we consider strength boost was player could just smash through obstacles, so there's no need for him to avoid them, and he's obviously unable to crash at the point. So in a sense, it's kind of like the invulnerability boost that we already have. So in order to save space, we're actually going to be using, we're going to be leeching off this one. So the way we've thought about our boost is it's something you can pick up during your run. So you can pick multiple such boosts during a single run if you find them on your way. That means that our boost is going to be triggered, is going to be generated by a source, since it can be found repeatedly. Now I'm going to set the source passive, and I'm going to name it strength boost. Hopefully I can type that correctly. Okay. And the way it's going to work is we're going to have a pool that determines whether the boost was used or not. So whenever we use a strength boost, we're going to send one resource. This is going to be named boost used. And it's going to work similarly to player crashes, in a sense that when we receive a resource in the boost used, we're going to just trigger the player is vulnerable pool that we have here. Do the asterisk as a label. Just going to trigger it, is going to push the resource forward and back, and our player is going to be invulnerable. Now, something we got to be careful here for is that our player might activate his strength boost while being invulnerable from crashing. So while he's already invulnerable, just activating the boost will do nothing. So we got to make sure that doesn't happen. So I'm going to condition the source for strength boost. I'm going to drag the arrows as best as I can. And so the strength boost is only allowed when the player is vulnerable, has at least one resource, so is greater than 0. Now, I've set this to passive. As Matthew said, the way we're thinking is we're going to introduce them first as sort of a tutorial, as in the player will use them. I'm sorry, just a
cat attack. Your cat likes the model.
My cats are attacking me, actually. Yeah. So sorry about that. So therefore, we're going to be having the strength boost be automatic and triggered deterministically. So we're going to do it with 20 steps of distance, I'm just going to drag a connection from distance to strength boost, which
I'll
means
tidy it
that,
up for you, Chizza.
yeah, please do, because I really dislike this part. I'm going to say the condition is after Matthew finishes arranging it. Yeah, I'm going to set the condition to greater or equal than 20. So when our player is past 20 steps of distance, he's going to automatically use a strength boost. Now, I'm going to use the 5% chance in here because we don't want him to continuously generate resources and use boosts. Or should we do it another way? No, it's fine. I guess there's a 5% chance he's going to use a strength boost and see what happens. I'm just going to hit play right now. We have our distance. Our strength boost is available. As you see, it sometimes pushes resources. Whenever it pushes a resource, our player becomes invulnerable. While it doesn't, our player crashed and we are unable to generate them. Now we are able again. And as you see, the player gets further and further. He's going to run out of life soon. There he goes. He's dead now. So that's it for our strength boost. It's just a couple of nodes and a few connections, and we have our boost in place. What we're going to be doing after introducing it to the player in a deterministic way is we're going to have it just generate randomly. So there's a chance that the player will find it on his way after the mechanic is introduced to him. So next up, we're going to be going with our speed boost. Again, the same system. I'm just going to copy paste what we have here and add the speed boost along it. Matthew's going to hopefully help tidy up the game over states and everything.
I'm just going to line all the other ones with your one, Chizza.
Sure. That's actually very helpful. So since we're not going to be doing it deterministically, we're going to be using a random gate to trigger this sort of situation. So I'm going to have a random gate here. I'm going to set it to automatic, and I'm going to, as you see Matthew arranging stuff to my left, I'm going to explain what I'm about to do here. So instead of having a source generate a resource with a 5% chance, we can just set it to 1 and have an automatic source that has a 5% chance to trigger that source. So what this gate essentially does is every step it activates, and when activating it has a 5% chance to trigger our strength boost for a single step. So think of it as a trigger, but with a 5% chance. So this is the same as we had before with the automatic source and the 5% chance here. Only that this time it's not going to be deterministic. It's going to start from execution start, and every step there's going to be a 5% chance that this situation occurs. So this is going to be our strength boost. I'm just going to call this activator because we'll be using it for much more. So let's leave it here. And the following one, I believe, was the speed boost. So I'm going to start with that one now. We thought about our speed boost as something that the player begins the level with. So it's not something that he picks up, maybe something he purchases from the shop or something, but he has it since the run starts. And he has only one use of speed boost. So I'm just gonna create a pool here, name it speed boost, give it a resource, and this is gonna keep track of our available speed boosts. Now, what our speed boost will essentially do is going to double our, what we thought about was it's going to double our distance gain for a couple of steps. We're thinking 10 steps. And the way we're going to implement that is we're going to be using a converter node. So what a converter node does is it receives an input. In this case, it's going to be one resource and converts it, as the name implies, to a desired amount on the output node. So we want to take one speed boost and convert it into 10 steps of duration. I'm just going to name this boost duration. So right now we're going to convert one speed boost into 10 steps of boost duration. Now, obviously, that duration is going to increase, it's going to decrease, sorry, every step. We're going to have an automatic draining here, and it's going to drain 1 resource per step. We also might want to see boost duration as a number rather than as resources, so I'm just going to set the display to -1. Now, how's the boost going to work? As long as the boost is active, our player gains double distance. How are we going to implement that? We're going to be using a register node. Registers are very useful, especially when using formulas, which is what we're going to be doing here. So I'm going to use a state connection, connect our boost duration pool to our register. As you see, the default label is A, which means that the value that we have in boost duration is sent to the register as variable A, and we can work with it inside the register. In here, I'm going to use a simple comparative function, which is larger A than 0. So what larger A than 0 does is it compares our number A to the number 0. If the number is larger, then it returns 1, and if it's not, then it returns 0. So while we have any boost duration in here, so the boost is active, it's going to return 1, otherwise it's going to return 0. And I'm going to use the result of that to double our distance gain. So I'm just going to connect it straight to our distance generating connection here. And going to take the result, which is either 1 or 0. And if it's 1, I'm going to multiply that 1 by 5 and add it to our distance. So as we did last time, I'm going to first generate it deterministically again. So we'll have to make this automatic and set it to push. So it pushes the resources rather than pulling it. And the condition is going to be the same as before. I'm not going to focus on the connection too much because we're going to remove it anyway. As long as the player has at least 20 distance, we will allow him to use it straight away. So right now, if I hit run, we're going to be accumulating distance. As soon as we get to 20, we use our speed boost. You can see on the connection, we have a 5 plus 5 while the boost is active. And as soon as it runs out, we turn back to the standard 5. Of course, this is useful because we get to the higher rewarding areas faster. So we can gather coins, multiple coins faster. So it's going to help the player. Now,
just a quick question in there. Someone's just asked, could that be ×2 instead of +5?
I mean, the meaning of the label +5 is as follows. Plus means that you add the amount to the existing label here, and 5 is the number by which you multiply the amount in the register. So if you want to make it 2 times the amount that you have here, it would be +2, not ×2, because you want to add the amount to the 5. A label of ×2 doesn't work as far as I'm aware. You want to match the amount that you have here and add it rather than try and double it, because that's not a valid statement. But it's a good suggestion for maybe a feature in the future. I can certainly see its use. Right. So if there are no further questions, we're going to be moving to our final boost, which is our personal favorite, the mega jump. The
Super
strongest
mega
of them.
ultimate jump, please, Cesar.
Super mega ultimate crazy galactic jump. I'm just gonna copy my system again and paste it with all the good stuff in it. Matthew's I'm gonna have him struggle align the rest after this diagram. Hopefully he'll remove game over as well.
Yep.
So the first thing we're gonna do is we're not gonna trigger speed boost deterministically anymore. So I'm just gonna delete this connection. And we're gonna have our activator handle our speed boost as well, because a gate like this can handle multiple nodes at a time. So since the speed boost is 1 per run, not a big deal, not something we should be used very rarely. Let's give it a 10%, because we kind of want the player to get some distance before he uses the boost, I suppose. I'll just give it a 10%, see how that goes. I'm not gonna bother with it too much. And our final boost is going to be our mega jump. So we thought about mega jump. It's going to be something like strength boost, where you can pick it up on the track rather than have a limited amount of it. but it's going to be super rare because it's going to be powerful. And just how powerful it's going to be, I think Matthew has a question. No.
Well, actually, I just thought for chat, like in the chat, how far do you think we should have the player leap forward with their super ultimate mega jump? Obviously, it can be any number. So in chat, just let us know what you think it should be and how many coins you think we should give them. And should it be a fixed number of coins or anything? So just in the chat, if you've got an idea how far they should jump, please do let us know. All the coins. Leet. Gotta love some gamer talk. So it's 20 distance for 50 coins is the current most sensible that I can make into a real number. Jump 50 and D100 coins. Cheza.
Yeah.
So let's do somewhere in the middle. Let's do jump 30 and let's do a D100. Maybe we give them a minimum as well. So let's give them.
Yeah. Let's give him between 50 and 100.
Yeah.
Sure. So it's going to be 30 distance and between 50 and 100 coins. Right. So the approach, this is going to be the easiest one to implement out of all of them, since it's repeatable and it doesn't really need other systems like the vulnerable part and stuff. We're just going to be, I'm also not going to trigger this one deterministically because it's a stronger one. We'll just give it the player straight away with a random chance. We're going to be using a source again. I'm going to name it Mega, hopefully if I can type correctly, Mega Ultra Galactic Jump. And what we're going to do with it is we're going to generate the coins and distance with a, first off, I'm going to give it a bit of a higher chance so we can see just how it works. So I'm going to give it an insane chance, I don't know, 40% or stuff, something like that. We're going to make it passive since it's going to be triggered by our activator here. The distance part is easy. We just draw our resource connection into it and we drag it. It's not perfectly centered. Now it is. I'm gonna move some stuff around here, make some space. Okay, and we're gonna generate our 30 meters of distance. And for the coins part, if you want to do between 50 and 100, we're gonna have to use our lovely dice label, which some of you know and some of you don't, so I'm gonna explain it again. So if I were to type D100 here, it would act like the first suggestion that Matthew said, where we gather between 1 and 100 coins. So D100 translates to a 100-sided die, and the result can be anywhere between 1 and 100. Since we want to, sorry, were you going to ask something?
I was going to say, we want to make sure that the player gets at least some coins. So
exactly. Since we want to do it this way, in a sense that the player gets at least 50, so it gets between 50 and 100, we can actually do it, add a deterministic number, which will be 49, and then add D51. So he's going to get a minimum of 49 plus between 1 and 51 coins, which is going to amount to our total of 100 tops. So a label like this is going to output the exact amount that we want. Now, I'm just going to hit play so you can see with a 40% chance the impact that the Mega Ultra Fantastic Jump has on our game right now. As you see, he's already in the third tier of resources, and he's getting a lot of coins. Now, compared to our last run, we are already at 580. Oh, this is...
Oh, I broke the last one. Sorry, that was me.
That's fine. Okay, Matthew messed them up. I'm not going to compare them. But we've never reached 1,000 before, so it's an easy 1,000 since we get it. So as you understand, the value is quite high. That's why I'm gonna let the player run out of lives here. There we go. It's game over. We got 1657 coins, which is a huge amount. So we're gonna tone down the chances a lot here. Rather than 40%, I'm gonna give it, I don't know, 2 or 1%. Let's just do 2%, I guess. No, let's just do 1 because it's so powerful. So we're probably gonna see this very, very rarely. It should be something that the player really is happy about when finding. It should be a rare occurrence, and it should really determine a player's score in a pretty important way. Now, we want to do one final thing to this construction, which is instead of having to run through a game over and resetting and running all over again, we want to create a loop of continuous runs. So we're going to remove the game over end condition that we had there, and we're going to introduce some resetting factors because we're going to have to reset the player's difficulty factor and distance and even boost durations, and we're going to have to give him his lives back and speed boost and everything else. So the first thing that we're going to do is we're going to use a system that Matthew particularly likes, which is having our player as a token. So our player can be viewed as a token going through our game. So we're going to use this pool to say that the player is in game. Let's call it in game. I'm gonna name it like that. Gonna set its resources to orange so we can distinguish the player. And we're gonna give it one token in there, which is gonna be our little player. So while the player is in game, we're gonna condition our sprint pool, which is basically our entire mechanism here. And the player can generate distance, difficulty factor, and so forward. Now, since after the player loses all of his lives, we're going to want to reset all of this and start over. We're going to need two additional pools here. So we're going to have our first one placed to the right here. I'm going to name it reset. I'm going to set it to automatic. I'm going to set in-game to automatic as well. You'll see why later. And we're going to have our player dragged into our reset pool as soon as he loses all of his lives. So since it's set to automatic, we should have a condition, and that condition should be that the player has lost all of his lives. So I'm just going to do that right now using a state connection, give it the condition equal to 0, so the player is out of lives. Then reset becomes active with the action of pull any is going to pull the in-game resource to reset. And what we want to happen when the player is in the reset phase, we want to reset all of his achievements, all of his distance, difficulty factor, and such stuff. So we're going to have our draining here. We're going to make it automatic. And we're just going to drag all of the resources that we have in difficulty factor. Since we don't know how much that will be, we can just label it as all, and it's going to drag all the resources that we have in the pool. Distance as well. I'm going to try and make it look a bit prettier.
I'll tidy it up for you.
Sure. And give it all again. And we also want to reset our boost duration because maybe the player dies while the speed boost is active, and we don't want him to start the next run with an active boost. So we're going to drain that as well, again, by all. I'm going to let Matthew handle that. So this is what we'll be draining, but we'll also have to be giving player stuff back, which is we're going to have to give him 3 lives, and we're going to have to give him a speed boost. Now, we don't need to give him any strength boost or mega jumps because he can obviously pick those up during gameplay, so he doesn't need them. Now, what we thought about speed boost normally is that maybe the player doesn't use a speed boost in one of his runs and dies before, runs out of lives before he gets to use all of those speed boosts. In that case, we thought that it would be fair to give the player another speed boost in addition to the one that he already has for the next run. So he can effectively stack them and use them, like 5 of them in one run if he so chooses to. So we're just going to be giving him 1 speed boost at every reset. We're going to be handling this part by using a automatic source, which is going to push 1 resource into speed boost and is going to push 3 resources into our lives counter. So I'm going to set this to 3. Yeah. So it's going to give the player 3 lives and a speed boost. Now, obviously, those are going to run continuously unless we tell them not to. so we should tell them not to. The way we're going to do that is we're going to activate them only when we have resources in our reset pool. By default, it sets the condition to greater than 0, so that's fine. I'm not going to change it anyway. So our two resetting nodes will only be triggered, will only be active while we have a resource in our reset pool. Now, obviously, because of this, we only want our resource to be in here for a single step, so we don't keep giving the player multiple lives. So we're going to need a third pool here, which is going to complete our loop, our player looping throughout the different states of the game. We're going to set it to automatic as well. We're going to leave it on pool, and we're going to name it, let's say, new game. So this is, let's consider this the screen when the player hits play again. So we have new game, and the new game is just going to pass the resource forward to in-game straight away, because there's nothing that's going to happen while we're in our new game. So as it is right now, everything should be reset. I'm just going to zoom out for a tiny bit so we can see all of the player journey. And I'm going to hit play. And as soon as our player is going to be in trouble, I'm going to pause and we're going to execute it step by step so you can see exactly what happens. So he already used his speed boost, so he's gathering distance like crazy right now. He's not finding any of those other boosts at the moment. He still didn't lose a single life, which is fine. Obstacles is not activating. Just a second, because there's something here. It's because of difficulty. Let me try again. You saw that obstacles wasn't activating due to our, yeah, it's activating now. So our player is gathering distance. He already used the speed boost again. He's using it like crazy, which is fine. He still hasn't crashed. We are already in the high reward zone. He crashed once. He's got 2 lives left. He's gathering a lot of coins. He used the strength boost, so he's invulnerable for the moment. As you see, he's still gathering a bunch of coins. He's doing fine. When we get to 20%, it should become a bit harder at every step. He's doing really well at the moment. We're to our last life. We're about 500 coins. We're probably not going to reach the 1,600 that we had in our previous run with the busted mega jump. There we go. We lost our last coin. I paused it here. As you saw, as soon as we lost our last life, our resource transitioned to the reset pool. Now that it's inside the reset pool, all of our resetters are activated in here. If I execute another step, it pushed the resource forward while also activating those nodes. So we pushed our speed boost back, we pushed our lives back, our difficulty factor is reset, our distance is reset, and we are ready for a new game. So if I were to hit just multiple instances of, let's do a quick run in here. Gonna tidy up the chart because we have those from our previous diagrams, which I copied pasted. Just gonna remove them all here. We don't really care about the other executions at the moment. And I'm just gonna add our coins for now and track them in our chart. Just gonna make the chart big so you can see it, clear it. Maybe do, it's 100 steps at the moment. Let's make 500 steps, not 5,500, and do a quick run and see what happens to our coins during multiple runs. So as you see, when the curve flattens a bit, it's usually because the player lost and it's back in the lower rewarding area. And when it gets a bit steeper, it's because the player is in the end game, so to speak, and is accumulating a lot of coins. So you can see those.
We can see our super mega jump there, where the player suddenly gets a huge.
Yeah, exactly. This here was a mega jump probably because the player got a large increase. This is a mega jump as well, so you can keep track of those in the chart as well. Now, of course, I'm going to pause. And you can see the chart, it went to a lot of coins. And the part with the coins, we're going to be using these coins in our next webinar, I believe, in order to simulate different shop mechanics or boost purchasing mechanics and stuff. But I believe Matthew has more information on that.
Yeah, so what I've been doing while you've been doing that, if you want to jump back over to the left and just show them how I've built our little player journey.
Exactly. So this is what I've been explaining with our little player here. Matthew's been connecting my diagrams together. He's placed the source here, which is set to on start on activation, which means that it will only trigger one resource at the beginning of an execution and then become passive. So that's what on start means. Only during the first step it does something. It's generating orange resources, much like my player is here. So it's going to generate an orange resource. It's going to take the player to the first stage of the game. We condition every sprint source by the fact that is the player present or not. So we're first going to do our first run. I'm just going to show you rather than explain. So we're going to do our first run here. Our player's coming in, he's starting sprinting, gets his coin, gets all of his stuff. As soon as he's going to lose his lives, this opens up due to the condition on the lives pool. It opens up our next stage. The player is going to move forward. He's already at his final life, so this should be over pretty soon. There we go. Our player transitions forward, and our second execution starts with the new systems in place, such as strength boost, for instance, this time the deterministic one. So as soon as the player is going to lose this as well, he's going to move forward and so on and so forth. Which can be used to compare the different stages of the game and how they generate resources, simulating an entire player journey. Like maybe the player is introduced with the strength boost in the third level of the game, maybe the speed boost is introduced in the sixth level in the game, and so on and so forth. So you can really simulate an entire player journey here.
Do you want to just link up that last one and we can then do a quick run of all the steps?
Sure. So the final part is going to be, we're just going to pull this one as well. This should be set to automatic. This is going to have 0 resources by default. It doesn't need to have orange resources anymore because it's going to come for the source. I don't have the patience to arrange it at the moment. We'll just do the conditioning the same. As you see, Matthew has set 2 conditions in here, which is one from lives, which determines that the player moves forward, and another one from lives that determines that the player does not receive coins anymore, because otherwise those 3 sources that are automatic would keep pushing coins forward even though our player lost all of his lives. So we're going to need to implement those 2 conditions as well. I'm going to have the lives pool condition our in-game pool, and of course equal to 0. And we're also going to condition the third coins pool here, which is going to be greater than 0. So now we should transition to our last run, and we should see all of them. Let me make sure there are no end conditions inside. Okay,
I've been a good boy and I've kept them tidy.
Yeah, thank you. So I'm just going to zoom out so we see the whole impressive model that we have here. We've excluded the first part, the classic tutorial that we had, but that's okay. And now we can keep track of all our various pools. Show them in chart, show in chart, show in chart. We already have them named differently. I'm also going to give them different colors. Let's see, gonna give this one green, and the last one I'm gonna make blue. So now we should be easier to track them. So you're gonna notice that so the first one, the orange one, oh no, we still have to color it in the same way. Oh no, it's just coloring it here. So you're gonna notice if I hit play right now.
I think you want to stop that and do it a little bit faster.
Yeah, no, just for a quick. So you're gonna see that only first coins is increasing. That's because the other runs haven't started yet. So we're actually gonna do an animated run, so you can see our player journey, how he moves forward, how he activates all of these systems as he goes. So I'm just going to hit run with a 0.1 speed, which is our fastest speed at the moment. Oh, this one's accumulating distance as well. It's not interrupted. Just a second. It should be conditioned equal to 0. Let me check for a bit why it starts. It's something, if anyone in the chat figures out why it starts, please let me know. It could be a good exercise. Oh, yeah, okay. It's because of our mega jump. It's because our mega jump triggered and it gave the player 30 distance. That's why this happened.
It's a deliberate mistake to see how easily things can go wrong.
Exactly. So you have to be careful about this sort of stuff. So our activator, because it's automatic, it's gonna push resources even without our consent. So we gotta stop it. So how are we gonna do that? The same way we condition the source from our in-game pool, we're gonna also condition our activator. Again, we have to have a resource here in order for the activator to work. So we're gonna have to do this for our other instances as well. Greater than 0. Not going to change the label. We don't have an activator here, so those two instances are the only one that interest us. I'm going to zoom out again. I'm going to clear the chart so you can see it better. I'm going to hit play again. Now we're not getting distance anywhere, which is fine. We're gathering coins in the first one. Our player already crashed once. We're waiting for him to finish. He's triggering invulnerability here, but it doesn't really matter as the player is not present and it's not affecting the execution in any way at the moment. We could also disable it by using the player is present pool, but I'm not going to do that right now. So we've transitioned to our second run. As you can see, obviously when we're going to lose our 3 lives here, we're going to move forward to our third one. And as soon as we enter the fourth one, we're going to be looping in around as I showed you earlier. So while we're watching these executions, Matthew, if our audience has any questions?
So I'd love to hear any questions that anybody has. So there's the option, we've got a Q&A box, or you can pop it in there. Actually, I've got to quickly, just off the back of some of this conversation that was going on through chat, I've got one more poll for you, which is, no, it says failed to launch poll. Oh no, there it is. It's worked. Good. So I'd just love to know, actually, it was coming up in chat of how many people are self-taught and how many people studied game design formally. I quickly copied and pasted that into something here. It'd be great just to, I'll be able to share the results with you in a couple of seconds once everybody's voted. This has been really good. So, just a few minutes, we've just been able to build a full game meta, and you can really quickly see how these start to look really complicated. But actually, in the past 50 minutes, we've been through the tutorial and we've built out this full game journey. Now, next week, we're actually going to take this same model and we're really going to focus, and now that we've built our game mechanics, we're really going to focus on monetization and how we're going to make this the optimal journey. We're going to look at adding adverts, we're going to look at adding in-game purchases, and we're really going to focus on that. Horea is now going to really kindly drop the link in to register for next week's panel. As always, love you to join us on Slack and Discord if you haven't already. I'm going to share the results of the poll. So here we go. So 69% of people were self-taught and 31% of people studied some form of game design formally. Brilliant. All of the webinars, so this webinar will be going up on YouTube in the next day or so. One more thing that we are going to ask you is that when we end this webinar, it's going to push you into a quick survey. We'd love it if you could just give us some feedback on today's webinar, but also let us know if there's anything you'd really like to see in any future webinars. Certainly, if you've got an idea of how we could monetize this, I've been keeping track of these as they've been going through the chat. It'd be great to hear what ideas you have of how we can monetize this, and we'll make sure to think on them and be ready for next week's interactive webinar. And as always, any questions, always feel free to come and ask us. Brilliant. Have I forgotten to say anything, Cesar? Have I covered everything?
If any of you have any questions regarding this model or any questions in general, just hit me up in the help here and ask me anything. I'll probably answer as fast as I can. If not me, Matthew or Mihai or someone else will pick up your question and we'll work it out.
Great. Thank you very much, everybody. I think this has been a fantastic example of what you can accomplish with Machinations. In 50 minutes time, we've built a full end-to-end game. So thank you all so much for joining us today, and we'll look forward to seeing you in future webinars. And please do fill out the survey. Oh, I should say, actually, if you're still there, if you fill out the survey, it'll take you directly to a link to this diagram so you can have a play with it yourself. Just in time, right? Thank you.